Hi, I'm going through setting up a simple bend deformer, and first I'm going to just remember that some of the deformers that we have available here in the Deform tab are basically something that happens in a line. So it's a distribution of two transform groups with a linear fall off. So there's this transform group and there's this transform group, and between them there's a fall off that distributes them. So let's say that this goes from 0 to 1, and so at 0 this one has full influence, and at 1 this one has full influence. And so basically there's a transition between which of these transforms is affecting the vertices. Now here I have shear, twist, and tapper, and so shear is about moving, twist is about rotating, and tapper is about scaling. And so these are the basic transformations. It's just that they have a linear fall off. And so that can be seen if I go here to Modeler, and if I choose, let's say, the Move tool, and I set the fall off to linear, and you can see that I'm shearing the mesh. And if I go into, let's say, the rotate tool, and I set the fall off to linear, if I rotate, you can see that I can twist. And if I go to the stretch tool and I set the fall off to linear, you see that I can tapper. And if I press the N button, you'll see that there's a setup going on where I have two positions, and at this position the value is 0, and at this position the value is 1. So it will stretch on this side, but it will stretch nothing on this side, and there's a transition between those two positions. So basically just what I was talking about in here. In this case, if I would reproduce what's going on in here, I would draw that little arrow thing like this. Now, these transformations can be attained in the single go by using some matrix transformation. So here in layout, I have a setup where I have two deformers performing the twist, the shear, and also the tapper, and they have a linear fall off being used to blend between both. So here I have object B and here I have object A. That performs the same thing but on the other side. So let's quickly look into that. It's basically a recap of something that we already looked into, which is the multiplication of a vector by a matrix, and also a root deformer setup. So if you're not familiar, or if you don't remember, there's an item that is considered to be the root, and there's the child item that is considered to be the deformer. And so each of these have a matrix. So the root, let's call it R, and deformer, let's call it D. So if I have a mesh, and I have basically both of them at the same location because I have the root in there, and I also have the deformer that is child of the root that is, at 0, 0, 0. So nothing has been changed into the position, rotation, and scale of the deformer. And so what I'm going to do to perform this sort of setup deformation is I'm going to multiply the vertices or the position vectors by the matrix of the root inverted, and then by the matrix, the result of that, by the matrix of the deformer. So this is the basic root deformer setup, where with this one I define the rest position, and with this one the difference that it has from the parent will cause a deformation on the mesh. And so for that, here I feed two items, and so I have item A and item B, and I access their roots. So in this case it's basically going to be the parents. So here I have A and I have B, and so the roots will be a parent, in this case B root, in this case A root. And I can access those inside of the compound by using an extended item info, and so I have this parent item output, which will give me the ID of whatever comes in here. And so the first, here's one root deformer setup, and here's another root deformer setup. And so you can see that the parent item goes into the first vector matrix multiplication, and what I use is the inverse of that. And then on the second one, I use the result, the straight up result. And the same thing in here. The first one is the parent, and I use the inverse of that, and then I use the straight up result. So those two are mixed together using a fall off. That fall off will be a linear gradient between the two roots positions. So here I have the parent item going into this extended item info, which allow me to get the world position of both A root and B root. And so those positions will be used to build up a linear gradient between the two positions. So unlike these deformers here that only work on the x-axis or the y-axis or the z-axis, these ones can work in any axis depending on how I do pose the roots. But so that linear gradient is going to basically distribute the two deformations. So this is basically what's going on in there. So let me demo that. So if I come here and I move this like so, you can see that I can change one side and then the other. independently. Now let's say that I change the position of the roots. Let's say that I'm going to put the B root, then I'm going to put it, let's say, here and here and here, so in this corner, and I'm also going to orient it like so. It's a bit like oriented like the vertex normal at that position. And so the root of A, I'm going to also pose it, let's say, here, here. Yeah, that looks good. And so I'm also going to orient it so it looks like the vertex normal in there, and so something like this. Right, so now I have the deformers, and as I move the deformers, you notice that now it's an oblique direction. It's not just X, Y, Z, but it's an oblique direction. If I twist this, you can see that going on, scale it, etc. So because the fall off is being constructed by a gradient that goes from this root to this root. Okay, so this is an example of having those deformers done with nodes. Now let's look into something that also happens along a direction, and it's the bend deformation. The bend deformation is a bit more complicated than just distributing a transformation along a direction, and so that's why I'm going to take a little bit of time looking into it. And so basically I'm going to do a simple setup, but then I will present the compounds that I ship so that basically maybe you can start off using that much faster. So here's a mesh, and let's say that I want to bend it. I define the axis. So in this case, I'm going to have a strict axis, so I'm going to bend it on the y-axis. And so this is going to be my axis of bend. And so then I define a minimum and a maximum value. And so that's why I have these two lines in here. And so that range of values will define my arc of bend. So whatever is inside these two limits will be bent, while what is outside will remain straight. So what's inside that range, I'm going to flatten it on the axis like an accordion. So everything is flattened down and up into the axis. Then after doing that, I'm going to move that a little bit to the side with some radius. So that's going to be the amount of how much I move it to the side will be the radius of the arc. And then I rotate that. And so after rotating it, now it looks like a bend, but I need to put it back where it was. So there's a bit of conjugation here with the radius, where I move it with the radius, I rotate, and then I put it back. Now let's look into some of the axes. So there's some important axes in here. So the tangent one, it's going to be these are just names that I'm giving to them. So there's a tangent axis where the fall off is going to take place, and so the fall off here in this case will be this range that we define here that this is going to bend, and so this is along this axis a fall off will be defined. Then there's this normal axis, which is going to be used for the radius and basically to define what's the direction of the bend, because in this case it's bending in this direction, but it could also bend on the same fall-off axis, but it could bend in this direction or in this direction or in this direction. So this is also going to be used to define the direction of the bend. And then there's another axis that is perpendicular to the other two. It's called the binormal, which is going to be used to actually rotate the mesh. So this rotation operation here is going to require an axis, and it's going to be this one that is perpendicular to the other two. So let me do a quick bend setup. I'm going to turn off the nodes for this mesh, and in this scene I'm using this here I'm using Studio Live, but now I can also use the auto refresh plugin to make things maybe a little bit faster at times. And so I'm going to turn that on. I'm going into the displacement node editor for that mesh. And so here I just basically have nothing happening. But so the first thing that I want to do is to check the values along my bend axis. And so in this case, I'm going to bend this mesh along the y-axis. And so that's the one where I'm going to define a minimum and a maximum. To make things simple, I'm going to set up my minimum to always be 0. So for simplicity here, the minimum is going to be 0. The maximum is going to be something like 5 and something that can be changed later. So let me look into that. So I'm going to split the positions, and I'm going to do a clamp. So to perform this pancaking here, what I'm going to do is I'm going to subtract the positions of the vertices along the y-axis. And so if I do that right away in here, so let me do a subtract scaled, and I'm going to put the y value in here, and here I'm going to make, I'm going to subtract, I'm going to define the direction, that is the y-axis, and this split vector is going to tell me how much. And so if I put this in here, you can see that right away everything got pancaked. Now I don't want everything to get pancaked. I want only the vertices that are inside of the range that I define. And so in this case, it's going to be something like 0 to 5. So I'm going to do a clamp to define that range. So let me put here scalar, and I'm going to put 0 on this one, and I'm going to put 5 on another one. And so 0, let me put the inputs by 0 to 5. And so by putting this in here, now I won't have all of them being pancaked into 0. There will be at the point that's going to stop. And so the ones that are below 0 won't be pancaked, and the ones that are above 5 will not be completely pancaked. They will come down, but they will stop at 0 at the base of the limit. Now with this done, I need to do the next step, which is to move the mesh to the side before I perform the rotation. So here I have to define a radius. Now, just like the wheel turning video, where I made a wheel turn and I defined a relationship between the movement, the distance of the movement, and how much was the angle that the wheel turned. There's the axis, the arc length formula, where basically it says that the arc length is equal to the radius times the angle of rotation. And so the arc length I already defined by defining a minimum and a maximum. And so to find the distance between the minimum and the maximum, I just do a subtract, scalar subtract. Doesn't matter the order, because after that I'm going to put an absolute, scalar absolute. And so this will give me the length of my arc. Of course, it's going to be 5, and I know that also already, because if this goes from 0 to 5, it's it's obvious that the length is going to be 5. But so I have here the method to find the length between the two values. And so I have the arc is already known, but now I need to define if I want to have this formula dependent on the radius or dependent on the angle. And so in this case, I think I want to input an angle and define the radius dependent on that. And so what I'm going to do is I need to find the radius. And so the radius is going to be equal to the arc over the rotation angle, because this angle I'm going to feed in. I'm going to change the angle, but I need to find the radius so I can perform this operation. And so I'm going to have here an angle constant node. Let me put 90 degrees for now. And so I'm going to scalar divide the arc length by my angle. Right, so by doing this, I have how much of a radius I have, but now I also need to define the direction of the radius. So here I have this direction, I have this other direction that both are perpendicular, and so I need to define what's the radius direction for now. And so to do that, I guess I'm just going to define it as being on the z-axis. And so I'm going to come here, I'm going to have a vector constant, and I'm going to have it go 0, 0, 1. And so I'm going to scale this vector by the amount of radius. And so I'm going to subtract by that. So you can see here that here I moved by the radius amount to this direction and then in the inverse direction. And so here I'm actually subtracting and here I'm adding. And so I'm going to do a subtract and an add. Here I'm going to add, here I'm going to subtract. So I'm going to put these two in here. And of course, since I'm subtracting and adding, it seems that nothing is happening. But if I just connect the subtract, you can see that there's a little movement going on. But this now is in perfect position so that I can rotate it. And so now this is the operation that I'm going to take care of, rotate. And so I'm going to rotate the vector, and I need to define an axis and an angle of rotation. So the axis is going to be perpendicular to both the normal and the tangent. And so to do that, I do a cross product, vector cross. And so in this case, I'm going to have that the axis of rotation is going to be the x-axis. And so I'm going to put this in here. And now I need to define the angle of rotation. Now, while I define here an angle value, as you can see in here, this is the angle value, not all the vertices are rotated the same. So these ones are rotated only half of it. This one's just 1/4. This one's just 3/4. So there's a fall off. That's why this is called the fall off axis. There's a fall off that goes on between this position and this position. This position here gets deformed full amount of the angle. This position here gets nothing, and between these two there's a gradient of values. So to find that, I just use the box step. And so the box step will give me a gradient between two positions. And so the bottom position will be 0 and the position will be 5. And so I pass the y value again in here, and I multiply that by the angle amount. And now I have a gradient of angle values. And so I plug that in here. And now you can see that there are values that go from 0 to 90 degrees. And so I have my bend going on. If I come here and I change this value, let me turn on Studio Live here just for a moment. You can see that I have the bend changing. And so as I change the angle, I'm also going to have my radius value changing. So at the moment, at minus 1.7, if I change this, you can see that now the radius gets to be -5. And so the whole setup now works accordingly. Now I could change the direction, and to change the direction, what I need to do in here is to rotate it. And so I could rotate this forward vector in on the y-axis. So I'm going to put here 0, 1, 0, and I can have here the direction, define the direction with an angle, with another constant angle node. And so if I rotate this, you can see that now I change the direction of the bend. I can also change the upper limit. And so instead of 5, let's say that I change this to 6, and you can see that now a bigger portion of the mesh is bent. Or if I go below that, you can see that the lesser portion of that is used on the bend section. And so this is a very basic bend setup, just so that you grasp the algorithm, you grasp the steps that go into making a bend deformation. You define a range, you squash the positions that are within that range to 0, and then you move it to the side along a certain radius, and then you rotate that along a certain angle, which there's some distribution of the angle. So here it's 0, here it's the value of angle that you define, and so there's a gradient between 0 and that value. And then you put it back in the same inverse direction in which you moved when you moved with the amount of radius. And so that's basically it. Now the compounds that I shape, they do have some, what they basically provide are some parameters to basically control that from the outside. And so here I have the most simple one, which is just called bend, and let's look into that. So here I have the object spot being bent, and I have this item info on this bend control that's basically going on into this item here. And so this item here, as I rotate it, as I move it, as I scale it, it's going to control several parameters of this compound. So if I connect this in here, you see that if I rotate this on the y-axis, I'm going to have some bend going on. The range is controlled by this min and max ports. So here these two ports will correspond to the range that I want to have the bend happening. So if I come here, let's say to 10, now I'm gonna have less of it, but 5, etc. I'm gonna have even less of it, etc. And then the angle is controlled by the y. The direction is controlled by the heading. As you can see, as I rotate this on the heading, the bend direction changes. And then there's also other things like an offset. So if I push this on the y-axis, you can see that I'm offsetting the origin of the bend. And I can also change the center. So instead of having the center be here, maybe I want the center to be on the other end. And so I can just pull this on the z-axis, and now it basically tumbles the center. And I can also scale the amount. So this range in here can be scaled by using the X channel of the item, or the Z. Yeah, in this case, I've put it on the Z. And so as I do this on the Z channel of this control item, I can change the range, the size of the range. So this is a very simple implementation, even though it's a lot of options. It's not too much of a mess, and you can see some of the steps in here. So here is the squashing. So the first off, since here I have the ability to choose the axis, what I'm doing is I'm rotating the mesh so that if I choose the y-axis, it's going to rotate the mesh to be aligned to the x-axis, because I've chosen the x-axis to be where my operation takes place. And so if I have a mesh that is oriented on the y-axis and I want the bend to be on that axis, what I'm going to do is I'm going to rotate the mesh so it's aligned with the x-axis and I can perform the operation as expected. In the end, after performing the bend operation, what I do is I rotate the mesh back to its initial orientation. So it's going to look something like this. So that's why I have this rotation operation at the beginning here with the being negated by this sine node, and also at the end. So it's put back into its original orientation. Then in between that, I have the pancaking. Of course, first I have the offsets, the thing that I've shown in here, this offset going on, and also I think it takes into account the center. But here I'm going to have the pancaking. In this case, the pancaking is going to be taking place on the x-axis. And so I have here the clamp, as you've seen before. And then after that, I have the subtract and the add operations, which give me the radius. So these two operations are here expressed by the subtract and this add node, as we've seen before, which basically comes from a radius, which is found the same way with the subtract absolute to give me the arc length, and a divide node to find the relationship between the arc length and the angle. And so this will give me the amount of radius. And then in between, I have the actual rotation going on, which instead of using a box step, in this case, I'm using a remap node to basically perform that gradient that goes from 0 to the angle amount that I define. I'm using this remap and some shenanigans here before that, where I have a minimum and the maximum, because I feed two values. So I don't feed 0 and the value, I feed some other value. And so basically I bend things on the top and I also bend things on the bottom. And so of course, if I come, let's say in here, and I change the minimum to say -5, and let me change this here, and let me change the center. So if I change the center to, let's say 0.5, so it is that right in the middle, you can see that now with this, I can bend things on the top and also on the bottom. Right, and so after the rotation and the radius is put back, here I have just a check to see if the angle amount is very, very small. I do nothing at all to the mesh. And so here this add is also connected to this subtract, which is basically the offsets. So the offsets are being subtracted in here. Actually, no, sorry, they're being subtracted in here, and they're being added in here. So you can see that there's all these sorts of conjugation operations. Here I talk about conjugation, but there's a lot more of those coming on this. So at the center of this operation is the rotation operation that performs the actual bending. But bracketing it, there are the radius operation. So I'm just going to put R in here. I'm just going to call it bend. So here's the bend operation, and bracketing it is the radius. And then bracketing the radius are the, let's say in this case, I have the offsets. So here I have to add the offsets. Here I have to subtract the offsets. So here I have the offsets. And then bracketing that, I have the orientation. So I have this rotate node and this rotate node as well, putting the mesh back into its original orientation. So depending on the axis value that I choose, I'm going to get some rotation of my mesh. And so all these operations, they basically build around this main operation, which is the actual bending. Right, so this one is a bit complicated, but it's not too extreme. I had two other more. I actually have one more that I'm going to show, and then I had another one that was even more complicated. But I decided to ditch it because it was too slow to be practical here in Lightwave. But so let's look into the next one and some of its features. So here I'm gonna disconnect this one, the nodal displacement, and I'm going to turn on the displacement node editor for these three mesh. And so here you can see the bending already taking place, also using this controller in here. And so let's check what's inside. So what's inside is basically another version of that compound, which I called Bend Plus, which has an additional parameter. So it has the curl, it has width, which is connected to the curl, and it has a method, and also has cut minimum and cut maximum, and also has a delta. So let's look into some of those. So the axis defines the axis of the bending, which is just like the other one. In this case, I'm using the y-axis, so that's why I'm putting 1 in there. The curl is something that does a pre-rotation, and so this is working just like the other one. But if I rotate on the bank, you notice that now there's some swinging to the sides. And so what the curl is that before I perform this rotation here, where I rotate around the binormal, let me just undo all these. Let me see if I can undo all these. Well, maybe not. I'm just going to delete this. Or just gonna press delete, it's easier. And so let me put this back into the brush. And okay, so the bending axis will for the rotation of the bend is this one. And so before performing this rotation, I'm going to do a rotation on this axis, on the direction axis. And so the mesh, instead of being upright, it will be a little bit sideways like this. And so since it's sideways, when it's rotated along this axis, it's going to do a spiral. And so this is what you can see. If I keep rotating this sort of does like a spiral effect on this tree. And if I rotate it on the bank, if I put 0 on the bank, there's no spiraling, right? But as I start to give some value on the bank, it looks more like a spiral. And if I rotate this a lot, you can see that sort of like constraining around an imaginary axis along this direction. Okay, so that's the curl. The width is used by the curl. So the curl, basically the width is, I'm telling the compound what's the width that is supposed to be taken into account. How much width is the mesh. And so if I put a very small value, I might have some trouble. So it's best to put here in the width a value that corresponds more or less to the width of your mesh. So this here will be the width, and this is the value that you should put here. Now it has a default value of 1, and so that's why it's working here. Okay, so let's look into other parameters. Here I have let's check the cut minimum and the cut maximum. So this is a value that goes from 0 to 1, and at 0 it does nothing, but at 1 it cuts the side that is it's naming there. So in this case, cut minimum, if let's say if I scale this on the x-axis down, notice that it's cutting the bend effect on that side. If I do this on the y-axis, it's going to cut the bend effect on the maximum side. And so this is useful to cut down the bend effect. On the z-axis, I'm going to have again the scaling of the fall off, and let's look at the other ones that we already looked into. So here on the y-axis, if I move it, I'm going to offset the bend. If I move this on the z-axis, I'm going to change the center. So this is a parameter that goes between 0 and 1, and so when I hit 1 here, it stops. And so then I have also a method. And so what method is that, if you remember, I told you that I was going to do the radius dependent on the angle. So I know the arc I define with the minimum and the maximum, but then I'm going to make the radius dependent on the angle. And so here the method is basically I can change that. I might not have the radius dependent on the angle. I might have the angle dependent on the radius. So basically I swap these and I find the angle based on the radius. So let's look into that. I'm going to change the method here from 0 to 1. And so now I have to give it a little bit of radius so it has some angle. And so the radius here is being controlled by the x position of this item. And so as I move this item on the x position, you can see that I have some radius, and now this adjusts to have some angle used on the bend. And so this is a way to give priority to something. So before I had priority given to the angle, and now I have priority given to the radius. Now let's look into the second method, or in this case the third method, in which I'm going to rename this here to method. And so if I put 2 in here, what I'm going to have is, instead of having one of these depending on the other, what I'm going to have is both of them contributing and basically coming to an arc. So I'm no longer, I'm modifying the arc that I defined initially by the both quantities of these two. And so if I don't have enough of radius and angle, the arc is not bent. So as I give more of angle, you can see that there's more bending going on. And as I give it more or less radius, that also affects the arc length. And so this basically is just another It's just another twist at this formula in which I have these two manipulating the amount of arc. So you can see as I move the radius, this changes, and as I move the angle, this also changes. And so it allows me to have this soft transition of this unwinding the bend as I want. And the last method is like a free method. All these methods use this formula here to basically have a consistent behavior. The last method just doesn't care about consistency. And so if I put 3 in here, you'll have to input some arc and also some radius. But you'll notice that now I'm going to have the mesh stretch. And so the arc is not going to be basically, it's not going to be reasonable. It's just whatever those two values are in there, that's what's going to happen. And so you can have results a bit wacky like this. So let me put this back into the first method, which is overall the one that is more common, which is to control the bend with an angle. And let me look into an input that doesn't exist on the other bend compound, which is the delta. So what's the delta doing in here? Basically, I have here a morph called flat. And what is this morph? Now, you'll notice that I have these branches, and those branches are bending nicely, right? But what if I take out the morph map in here? Well, now they look a bit stretched out. These ones, they look too thin, and these ones, they look like smeared. So if I have that morph map in there, this looks better. And so why is that? Well, the reason for that, let me go in here and check the tree object. You notice that these branches, they have different y values. So I'm choosing the y-axis as my axis to check the fall off, to build up my fall off. And so I'm using the y-axis to do that. But you notice that the branch, the vertices, they have different y-axis values, right? It's not just a single y-axis value. And so the morph, what I'm doing with the flat morph is I'm putting everything on the same position along that axis of bend, so that when the bend builds up the fall off, that is going to be used to distribute the angle of rotation. It's considered the same for all the vertices of the branch. And so there's no parts of the branch that have more rotation than others. They all have the same value by pancaking them on the axis of rotation. And so that's why when I put this in here, this looks better. So this is a quick overview of this bend compound that has all these options. Let's look into it applied into several contexts. So here I'm using it to deform a mesh. Here I'm using it in displacement. But I could use it for other things. I could use it for instances, for example. So let me turn this off, keep things responsive, and I'm going to this instancer object. And if I activate this instance generator, you notice that I have some instances going on. So let me come here, and I'm going to turn off the nodes. So I have an array on the z-axis. And that array will be basically bent. This array of instances is going to be bent by the same compound. The only difference here is I'm taking out the influence of the item itself. But other than that, it's basically the same setup. Now, in this case, the case of the instances, I'm not just bending positions. In the case of the mesh, I'm bending the positions of the vertices. In the case of the instances, I also want to orient the instances so that they go along the bend. So let's say that I take out this rotation output and let me activate the nodal setup and use nodes. And I'm going to reset the control item. And so as I rotate this, you notice that now the instances are not aligning with the bends. And so that looks quite weird. So in this case of the instances, I also have to have the rotations being used, not just the positions or the delta of the positions, but also the rotations so that the instances can be aligned with the bend. Now you notice that the axis here, instead of being 1, is set to 2 because I'm bending on the z-axis. And so this is why the same controller can be used for both bend operations. And I can also curl this. And so if I rotate this a lot, you can see that the instances sort of curl, and I can cut off the effect by using the X or the Y axis on the scaling and all those other options that I've shown previously. Okay, let's look into another example. I'm gonna look into the position of an item. And so here I have this item, and the item is just moving along the X axis from 0 to frame 60. And so I can also bend these positions. I have to have them keyframe. So in this case, I just have a keyframe at 0 and a keyframe at 60. So in the nodal motion of this item, I have the same compound being used. Let me turn off the instance generator. And so I have the same compound being used, and you can see that the path of that item is now being bent. And so here is the path without nodal motion, and here the path with nodal motion. And so it's a bit difficult to show because when I select this, I stop seeing the path. But let's say that I rotate this a little bit more even, and now you're going to see a very curly path, right? And so in this case, the rotations are also being used to align the item with the bend. So you can see as I move the timeline, not only the position of the item is being adjusted to the bend, but also the rotation of the item. Now let's look into another application of this. So in this case, I'm bending the positions of the item itself. And the last one, I'm showing all these operations just to show, to exemplify that these things work on vectors, irrespective of context. So here I was bending a mesh, then I was bending some instances. Now I bent the path of an item. And lastly, I can also bend the texture of an item. And so here I have, let me put this, the bend plane visible on the vertices, and let me focus on that. So of course, now this looks quite ugly. So let me reset the bend per control object. And so this is just a grid. And if I go into the surface editor, you see that the same compound is going on, and I'm bending the spots of this surface. And so here's the grid, and then I'm replacing the object spot of the grid with the bend spots. I'm going to talk about briefly about the replace spot in the next video because I think it's worth it. But here, basically, let's say that I'm bending the texture positions that are used to assign the grid position to the mesh. And so when I do this, let's say here, and I change the direction, let's say that I'm going to put this at 90 degrees, which seems to be aligned with the mesh. So when I do this, you can see that now I'm bending this texture, because I'm just bending the spots used for texture assignment. And so as I, let's say, offset this, you see the bend having a sort of a sweep. Or if I cut off the effect from one side or from the other side, you see all these things going on in a different context that is not just mesh or instances, etc. So this is a quick demo of bending algorithm and the compounds that go with the tutorial. Hopefully this will be interesting to look into, and this is something that you can open up and study and apply to other applications at your so it's at your disposal to basically grab whatever is going on in here and apply it in other places. Next, I'm going to, like I said, quickly talk about the replace spot, because it's not too complicated, but I think it's something that I overlooked in the series, and I think it's worth a video about it, just about it. Cheers.